The other two were together. I shouldn't record the technical comments. It doesn't really make sense when you look at them. But anyway, last thing today, 5 minutes. To sample. There is a method box coming up that is exemplified by this. That we compare two things by the non-parametric bootstrap, right? And the data example we've brought for this, another funny little data example that you have to read and think to really get it. Let me see if I can reveal it with a few words. Basically, I think if we look at the R, it's clear what kind of data we have. I have two groups of data. The data I have, the numbers, which is the age of some children, and they come in two groups, these children, those that were giving bottle and those that were not giving bottles as infants. And then this is data to investigate tooth health. So we have registered the age of the first time you get a specific kind of tooth problems. So that is, the older you are, the more tooth healthy you appear to be, right? Because then it took a longer time before you had any kind of problems. So we have the age of two different groups here. We want to compare. Does it look worse or better for those with or without bottle, right? What's the comparison of children with to the children without bottle? The means compared by non-parametric bootstrap now. So without assuming any distribution, this is a kind of data also, it was brought for that purpose, where again, such a categorical age doesn't look normal at all. And if anything, if we should argue anything, the waiting time until you get problems, you would argue in terms of an exponential, if anything. Because waiting times, but you can argue from here to wherever you want to go. It also depends on what actually hits you in the face when you get there. We have a two-group situation exactly like Peter talked about the day before, or the week before the break. He was here instead of me. So we replicate from the X samples, we replicate from the Y samples. I do my non-parametric resampling, where I resample from the data itself. Right? Here's the data. Look at that. Instead of having a distribution as a function of the mean of the data, I have the data itself. So I resample from the data itself, and then this was step 1. Compute all the differences of means and look at the quantiles. Now I repeat myself for I don't know how many times. Here is the procedure. I'm not going to spend many seconds on it now. It's the fourth method box and the last one. Copy almost of the other ones. Focusing now on the two-sample setting and focusing on the non-parametric version of the simulation. Not the distribution, parametric version, but the non-parametric without distribution version. And otherwise, it's the same as before. And finally, the last example, 2 seconds, where we could also compute anything else. For instance, the medians here, right? Or Q3 based on my own Q3 function or whatever. Very general tools. I hope you got the point here that, to finalize, I've given you the 4 method boxes. With or without distribution, we call it parametric or non-parametric bootstrap. That's the global names for these type of procedures. 1 or 2 sample analysis. Question?
In the 2 sample analysis, do we have to worry about the data being paired or not?
The question is whether I, in the 2 sample analysis, worried about data are paired or not. And yes, I do. When I talk about 2 sample analysis here, it's by definition a situation where they're not paired, where they're truly independent samples data. That's what I'm talking about. When I have paired data, it boils down to a 1 sample thing, right? So yes, I care just as much as I cared before the break. We have seen this big extension that we can actually, by these tools, do statistics not only on means, which is, probably you don't appreciate this generality or this level of what I've given you here. I hope in the future you'll sit out there when you go to my funeral. You're invited. In 20 years from now, hopefully, and you say, hey, he was right. It was pretty fantastic what he taught me that day. Then I would be happy. Post hoc happy. And then a final thing. I only talked about confidence intervals today. We can also do hypothesis testing by these tools, actually. We'll only take it as far here as to say, you were also already taught before the break that whenever I can do a confidence interval, I can also do hypothesis tests, right? Because a confidence interval shows me which values that I will accept on the two-sided hypothesis test, right? So a confidence interval tells me the results of all possible two-sided, non-directional hypothesis tests. So by looking at the simulation-based confidence intervals, I can also do hypothesis test conclusions. I could also simulate p-values, but I haven't shown you. So we don't find p-values here. I just get, do we reject or not? I can answer yes or no by these procedures, by the confidence interval, right? It's not that the other thing could not also be done, but we only have as much time, right? I already went over time. So that's what we did. It's a pretty fantastic piece of tools. You need to know how to deal with these tools in the 1 and 2 sample settings that I have explicitly given in method boxes. But I hope you get the idea that these tools go very much beyond those particular applications in the rest of the course and in the rest of your life. So good luck out there.